Alright, pre-calc students, so today is our last video in conics, in the conics section. It is on writing equations of parabolas. Similarly to when we were writing equations of ellipses or hyperbola, we need to have a little set of information and kind of like some rules so that we know when we're finished and we're ready to write the equation. So, if we think about this, we remember we have two different possibilities. We can either have a parabola that opens left and right, or a parabola that opens up or down, And what you really need to understand, guys, is that regardless, I need the h and the k, right? If I need h and k, that means I need the vertex point, and then I need the a value, all right? I need the a. All right. So these are the two things that I need in order to write the equation of a parabola. So let's think about this a little bit. All right, write the equation of the parabola with vertex 1, 0 and focus 6, 0. All right, well, let's get started by drawing a picture. Always draw a picture. I'm running it. Draw a picture. So we want to write the equation of the parabola with vertex 1, 0 and focus 6, 0. Well, let's do it. 1, 2, 3, 4, 5, 6. And I then can put my focus at 6, 0. I can put my vertex at 1, 0. And if you remember correctly, we have no choice but to make our parabola opening to the right. Something like this, and like this, all right? That's pretty important. Now what we do need to remember is if our focus is 6, 0, we can also sketch in our directrix. Because if you remember correctly, the p-value, or whatever distance you go from the vertex to the focus, is the same distance in the opposite direction to the directrix. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and now I have a perfect sketch of this parabola. All right, excuse me. Well, let's think about this. 1, vertex. I have it. I already have it. The vertex I was told was 1, 0. A value. Got to do a little bit of work. And so the big concept here that you have to remember is your formula for A, or formula that involves A. If you remember, P is always equal to 1 over 4 times A. All right? And so in this case, with P equaling 5, I can plug in. I can cross multiply. So when I do that, what do I get? I get 20 A equals 1, or A equals 1/20. All right. So now that I have my A value, and I already had my vertex, now I can write my equation. All right. Ooh, and you know what? I should add this to the list. I'm going to add 3. Let's talk about direction. All right, my bad, guys. So for this one, I'm going to put this over here, direction. We know that this has to go left, right. And we know that because the vertex and the focus were to the right of each other, left and right of each other. All right? Okay, so now I'm ready. If I'm going left, right, I know I'm going to use x minus and whatever that vertex point is. So I'm going to say x minus 1 equals, I have my a value, 1/20, and then I should just have y minus nothing, so y squared, something like that. All right, and you could leave it just like that. If you don't like the parentheses, you can get rid of them. Please remember, a positive a value either means it's going to the right or up. If we had gotten a negative a value here, we would have known that we were wrong. Why? Because our picture should have been going to the left. All right? Okay. Let's try another. Oh, okay. So right there, we have a focus now in the directrix. Let's sketch as much as we can. Ooh, not the best line, sorry. 6, negative 4. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. All right, so let's see what's going on here. I have a focus at 6, negative 4. 6, and then 1, 2. So right here, down here. There's my focus. I also have the directrix already at y equals negative 2. Okay, now that's really important, and we need to remember that the vertex of a parabola is always directly between the focus and the directrix. So if this is here at a y value of negative 4 and the directrix is negative 2, well then I know that my vertex has to be right there, smack dab in between. And then again, it's kind of it has to kind of hug the focus, so something like this. All right. So there's a nice sketch, and now I think we're ready to figure out some information. All right, so my vertex here, I've got it. It was this point right here, right? So 6, negative 3. A value, not quite sure yet. We can get that in a second. And then 3, I know that this is up and down. All right, why do I need that? Well, because that's going to dictate whether I'm using x minus h on the left side or y minus k on the left side. So let's make sure we get that a value. And to do so, we have to get the p value. We have to know that p in this case is 1. The distance between the focus and the vertex is 1. So 1 is equal to 1 over 4a. If I cross multiply, I get 4a equals 1, or a is equal to, ooh, what did I do wrong? Someone help me out. Maybe we won't make this mistake again. We have to remember that if if we're going down to the focus from the vertex, then actually our p value is negative 1. I goofed up. Sorry about that, guys. So p is equal to negative 1. Which means I have negative 4a is equal to 1, which means a is equal to negative 1/4. At the end of the day, I guess I wouldn't have worried too much about this. You would have had to make the connection, though, when you went to write your equation. What's true? This is opening down, so of course, when we write our formula here, which again is up-down, so we're going to start with y, and then I'm going to add 3. I need to know that this a value should, of course, be negative. All right, hopefully that makes sense, right? If it goes down or to the left, a should always be negative. So that's something just to also check. And then x minus 6 squared. And that should be good, right? Negative 6, negative 3, a of negative 1/4. Perfect. All right, okay. Last, writing an equation of a parabola. Okay, so write the equation of the parabola that passes through the point. Okay, we like these, right? These are fun. We have the vertex and has a line of symmetry, y equals negative 2. Okay, well, in this situation, guys, this is actually just straight algebra 2. I could sketch this, right? I know 3, negative 2, so 1, 2, 3. 3, 1, 2, 3. I know that my vertex is going to be right here. What's really important, being given this idea that we just have the vertex is dangerous. All right? If we have a vertex of 3, negative 2, we don't know if it's opening up or down, left or right. So the idea here, they need to give us this extra piece of information that we have the line of symmetry at y equals -2, something like this, because then that tells us, no matter what, that our parabola must open left or right. Okay? Now, if the parabola passes through the point 1, 0, which is where? 1, 0, right here. Well, can it open to the right? No. It's got to open to the left. Something like that. All right? Not the best picture, but again, that's kind of the thought process, right? If the line of symmetry had been x equals, then I would have had an up or a down situation. All right? So I have the vertex. It's 3, -2. I don't have the a value. And I do know that it's going left, right. Now, the problem here, I don't have a focus or a directrix either. What I do have is I have this extra point. So this is 1, and hopefully you remember from the last few, or for ellipses and hyperbolas, that you want to write out the equation as much as possible. All right, so if it's going left, right, I know it's going to be an x minus h situation, or instead I'm going to say x minus 3 equals, I don't have a, and I do have y plus 2. Because now, again, I can plug this point in. I can plug this point in. So 1 minus 3 equals a, and then 0 plus 2 is just 2 squared. So if I keep going, I get -2 is equal to 4a, a equals -1/2, and now I have my a value. Okay? So this is how we finish up the problem. I now can write my full equation with the a being replaced. So x minus 3, -1/2, y plus 2 squared. All right? Okay. So that's it for writing parabolas. The last thing that we're going to do is we're going to just review eccentricity a little bit. All right. Eccentricity is really just a way for us to classify these conic sections. Okay, we have some ideas, and we know. I'm going to skip a little bit. The eccentricity of a circle always has to be 0, and the eccentricity of a parabola always has to be 1. All right, and that kind of comes from the fact that, well, for a circle, distance from the center to the focus. Well, the focus is at the center. I know that's kind of goofy, but the focus is at the center. So your numerator is going to be 0. So whatever you divide by is going to be 0. All right. Now, we do need to remember for ellipses and hyperbolas that it's a little different. All right. For ellipses, we use r sub f over r major. And for hyperbolas, we use r sub f over r transverse. And it might also be good to remember, for ellipses, r sub f squared is equal to r major squared minus r minor squared. That's probably too small. I hope you can read it. Sorry. And r sub f, sorry, for hyperbolas, r sub f squared is equal to r transverse squared plus r conjugate squared. All right, so that's a little review. We know then, no matter what, when you have the eccentricity of an ellipse, or when you're finding the eccentricity of an ellipse, this is how you classify it as an ellipse. The eccentricity has to be between 0 and 1. And the closer it looks to a circle, the closer it is to an eccentricity of 0. The wider or skinnier or flatter the ellipse looks, the closer it is to 1. All right. Same thing on the other side. it's kind of flipped inside out now. So the closer it is, the skinnier it is. Oh, and sorry, eccentricity of hyperbola has to be greater than 1. All right, so the skinnier it is, the closer it is to 1, but from the positive side. And maybe I'll add that right here. This is 1 negative, or not negative, from the minus side. So, how do I say this? Below 1. Now I'm just confusing you guys. Great. Okay, 1 positive means above 1. And then, I mean, this can get as big as you want, right? I'm as big as it wants. I don't know what I'm saying there. Sorry, guys. But again, the idea here is the skinnier the hyperbola is, the closer that eccentricity should be to 1. But again, it has to be above it. Alright, so now to calculate the eccentricity for both of these, we need to get the r sub f. Now I see a minus sign, which tells me that this is a hyperbola. So my r trans and r conjugate, well, my r transverse is just going to be the square root of 4, or 2. This r conjugate should be square root 21. And so when I go to get r sub f squared is equal to 2 squared plus square root 21 squared, or r sub f squared equals 25. Alright, that's just me squaring everything, which then means r sub f should be 5. So now when we go and we actually get the eccentricity, E equals r sub f over r trans E equals 5/2. And what do you know? It's greater than 1. Just what we were looking for. Alright, now in this last one, I'm seeing addition, which tells me it's an ellipse. So now I have r major and r minor. Well, the major is just the bigger radius. And it looks like if I have a 9 and a 4, well then my major is going to be square root 9, or 3. My minor then will be square root 4, or 2. And so now when we calculate r sub f, it's major squared. Yeah, I guess I didn't need to write that again, but whatever. Okay, major squared minus minor squared. So I'm just going to have r sub f squared is equal to 3 squared minus, that's a 2, minus 2 squared. 9 minus 4 is 5. Or r sub f is equal to the square root of 5. Now, when we go and we calculate, eccentricity should be r sub f over r major, or in this case, E is equal to square root 5 over 3. Now, just to kind of check and make sure, square root of 5 is between square root 4 and square root 9, so this is definitely less than 3, right? And anything less than 3 divided by 3, of course, will be less than 1, which is what we were looking for. Alright, so that was just a quick little review of eccentricity. This was technically, I think, the last material I will teach you for the year. Our next videos will really just be some recap videos to get you ready for your final. Alright? It's been quite a year. It's been fun. Yeah. I'll see you guys in class where we can practice some more. Later.